Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are beginning a new topic today on relations, mapping and functions. In this video, we are going to consider relations. In the subsequent videos, we will consider mapping and functions. Now let's begin with relations. What are the objectives that we look forward to achieving at the end of this topic? At the end of this topic, you should be able to differentiate between a relation, a mapping, and a function. You should be able to find the rule of a mapping. You should be able to find the range of a function when the domain is given. Don't worry if you don't understand these terms, you understand as the lesson goes on. And you should be able to find the value or values that makes a function undefined. So at the end of this topic, you should be able to achieve these four main basic objectives. Now, let's begin with our topic of the day, relations. Let's consider the following statements. Statement 1. Amma is the sister of Kofi. Statement 2. Kojo is the son of Mr. Danso. And statement 3. Akuya is the daughter of Mrs. Kwarteng. Now we can see from here that in each of these statements, we can see a relation or a relationship. Amma is Kofi's sister. Kojo is the son of Mr. Danso. Akuya is the daughter of Mrs. Kwarteng. So we can say Amma is related to Kofi. Kojo is related to Mr. Danso and Akuya is related to Mrs. Kwarteng. Now in each case, we can see in the first instance that Amma is a separate human being on her own. So is Kofi. Now Kofi is being linked to Amma by the statement is the sister of. The statement is the sister of gives us an indication that Kofi is related to Amma. In the same case, the link between Kojo and Mr. Danso was seen because the statement is the son of gives us an indication that Kojo is related to Mr. Danso. The same applies to Akuya and Mrs. Kwarteng because Akuya is the daughter of Mrs. Kwarteng. So in the first instance, Amma is being linked to Kofi by the statement is the sister of. In the second instance, Kojo is being linked to Mr. Danso by the statement is the son of. And in the third instance, Akuya is being linked to Mrs. Kwarteng by the statement is the daughter of. These are relations or relationships that we see in everyday life. These things also happens in mathematics. Sometimes we may have a set, two sets. Now these two sets can be linked by a statement. The statement can be in form of words or a mathematical expression. Now when you have two sets and they can be linked by a statement, the statement linking those two sets is what we refer to as a relation. So in this case, Amma is linked to Kofi by the statement is the sister of. So the statement is the sister of is the relation in the first instance. In the second instance, Kojo is linked to Mr. Danso by the statement is the son of. So the statement is the son of is the relation. In the third instance, Akuya is being linked to Mrs. Kwarteng by the statement is the daughter of. So the statement is the daughter of is the relation. Just as we can see this in everyday life, the same thing also happens in mathematics. So when a statement can link two sets, we call that statement a relation. So just as we said, a relation is a connection between two sets. A relation associates elements of one set to the elements of another set. Let's take an example. Let's take the set A. In the set A, we have the cities Kumasi, Accra, Sunyani, and Tamale. In the set B, we have the regions Greater Accra region, Northern region, Brong Ahafo region, and Ashanti region. Now we can see that these are capital cities and these are regions, and we can link capital cities to the regions. So Kumasi can be linked to Ashanti region, Accra can be linked to Greater Accra region, Tamale can be linked to Northern region, and Sunyani can be linked to Brong Ahafo region. So the statement linking these two sets is what we refer to as the relation. So in this instant, we say that the relation is the capital of. So the relation in this instant is the statement is the capital of. Now let's try and see if this can work. So we are saying that the statement is the capital of is linking members of set A to members of set B. So let's take the first member of set A. So we can say that Kumasi, then we pick the relation, is the capital of, then we pick the image here, so Ashanti region. So we say that Kumasi is the capital of Ashanti region. The same applies to Accra is the capital of Greater Accra region. Sunyani is the capital of Brong Ahafo region, and Tamale is the capital of Northern region. So the statement is the capital of is linking members of set A to members of set B. When this happens, we say that the relation is the capital of. So the relation in this case is the statement is the capital of. Now let's go ahead and learn some terms about relations. When you have a relation like this, we say that the set of cities in A is called the domain of the relation. Now let's look at the direction of the arrow. You see it moves from left to right. So it's moving this way, and because it's moving this way, we see that members here, members that are at this side of the arrow, we refer to them as the domain. The members that are here are referred to as codomain. So members in set A here are referred to as domain, and members in set B here are referred to as the codomain. Remember, you can always find the domain and the codomain looking at the direction of the arrow. So the arrow moves from here to here, so it moves in this direction. When it moves in this direction, then those on the left side are called the domain, then those on the other side or the right side are called the codomain. So we've now known what a domain is and what a codomain is. Let's move on and learn some more terms about relations. If an element, say X, of the domain is related to an element, say Y, of the codomain, then Y is the image of X under the given relation. Now what does this mean? I'm going to pick an example to explain this. So we can see from here that we have seen in the previous slide that Kumasi can be linked to Ashanti region. Accra can be linked to Greater Accra region. Sunyani can be linked to Brong Ahafo region, and Tamale can be linked to Northern region. Now we know for sure that Kumasi is related to Ashanti region. That's why it's saying that if an element X of the domain, so in this case let's assume that X is Kumasi, is related to an element Y of the codomain, Kumasi is related to Ashanti region, so let's say that Y is Ashanti region, then Y is the image of X. So what it means is that if Kumasi in the domain is related to Ashanti region in the codomain, then we say that Ashanti region is the image of Kumasi under the relation. I hope it's clear. Kumasi is in the domain, Ashanti region is in the codomain. Kumasi is related to Ashanti region. So we say that Ashanti region is the image of Kumasi under the relation. Don't forget that the relation in this case here is the capital of. So under the relation is the capital of, we say that Ashanti region is the image of Kumasi, because Kumasi is in the domain and Ashanti region is in the codomain, and they are being connected. In that same way, we can say that Brong Ahafo region is the image of Sunyani under the relation. Northern region is the image of Tamale under the relation, and Greater Accra region is the image of Accra under the relation. Let's take another example. We can see from here that 2 is linked to 4, 4 is linked to 16, 5 is linked to 25, 6 is linked to 36. Now from here, we can say that 4 is the image of 2 under the relation. 16 is the image of 4. Sorry. 25 is the image of 5. And 36 is the image of 6 under the relation. So members here are what we refer to as the domain, and those here are what we refer to as the codomain. Let's take another example. Let's say in this case 26 is linked to 52, 7 is linked to 14, 4 is linked to 8, and 18 is linked to 36. So we can say that 14 is the image of 7, 52 is the image of 26, 36 is the image of 18, and 8 is the image of 4. Once again, those here are what you refer to as the domain. This set is referred to as the domain, and this set is also referred to as the codomain. Now let's learn another very important thing in relations: the range. The range is the set of all possible images of the domain, and the set of all possible images of the domain is what we refer to as the range. So when you come here, you can see that all these here are possible images. These are what we refer to as the images. All of them, if you take them one by one, so 8, 14, 36, and 52, all of them in one set is what we refer to as the range. So if you take 8, 14, 36, and 52 in this case, we say that you have the range, the set of all possible images. The set of possible images that the domain can produce is what we refer to as the range. In the same way, in this example, 4, 16, 25, and 36 is what we refer to as the range, the set of all possible images. In this example, Greater Accra region, Northern region, Brong-Ahafo region, and Asante region is what we refer to as the range. So the range is the set of all possible images that the domain can produce. Let's move ahead and look at some types of relations. We are going to consider the first type, called the one-to-one relation. In this relation, each member of the domain has only one image in the codomain, and each element in the codomain has only one element in the domain. That is clear, right? So in one-to-one relation, each member here in the domain has only one image in the codomain. You now understand what a domain is, what a codomain is, and what an image is. So these are members of the domain, and these are members of the codomain or the range. So we say that in one-to-one relation, each member in the domain has only one image in the codomain. So you can see from here that 2 has the image 4, 4 has the image 16, 5 has the image 25, and 6 has the image 36. Now, it doesn't end there. Each member in the codomain has only one element in the domain. So when you come here, 4 is also having only 2 here. 16 is related to only 4, 25 is related to only 5, and 36 is related to only 6. So it's one-to-one, one-to-one. Each member in the domain maps on to only one member in the codomain, and each member in the codomain relates to only one member in the domain. So when that happens, we say that we have a one-to-one relation. So in this case, you can see that the relation is the square of, so you look at this, 2 is the square of 4, so that is the relation. 4 is the square of 16, 5 is the square of 25, and 6 is the square of 36. So that is the relation in this case. So this is an example of a one-to-one relation. Let's look at another example. So when you come here, you see that 26 goes on to 52, 7 goes on to 14, 4 is related to 8, and 18 is related to 36. In the same way, 14 is related to only 7, 36 is related to only 18, 52 is related to only 26 and 8 is related to only 4. So whenever you have this, you say that you have a 1-to-1 relation. And in this example, the relation is half of, because you can see from here that 26 is half of 52, 7 is half of 14, 4 is half of 8, and 18 is half of 32. So the relation here is half of. Let's look at another type of relation, one-to-many. In this relation, one element in the domain has several images in the codomain. So in the previous example, we saw in the previous type, we saw one-to-one. This is one-to-many. So in one-to-many, you can see that one element in the domain has several images. When you say several here, several is 2 or above. So if it's more than 1, it's considered as several. So it has several images in the codomain. So in this example, 2 has the images 4, 6, and 8. 5 has the images 15 and 25. So unlike the previous one where 2 had only one image, in this case 2 is having more than one image. So we see that it is one-to-many. One in the domain maps onto many in the codomain. Let's look at the next one. So in this case, the relation is a factor of. So we can see that 2 is a factor of 4, 2 is a factor of 6, 2 is a factor of 8. In that same way, 5 is a factor of 15 and 5 is a factor of 25. So the relation here is a factor of. Let's look at the next type. We have many to one. So we've considered one-to-one, we've considered one-to-many. We are now going to consider many-to-one. In many-to-one relation, several elements in the domain have one image in the codomain. Now let's look at an example. So you can see from this example that 4, 6, 8, and 12, which are all in the domain, they all have only one element in the codomain. So 4, 6, 8, and 12, all of them are related to only one element, which is 2. 15 and 25 are related to only one element, which is 5. So when this happens, we see that we have many to one. Many in the codomain mapping related to only one element in the domain. I hope that is clear. Many in the domain relating to only one element in the codomain. Sorry. So many in the domain relating to only one element in the codomain. So we have 4, 6, 8, and 12 relating to only 2 in the codomain. We have 15 and 25 relating to only 5 in the codomain. So when this happens, we say that we have many to one relation. Try and see if you can find the relation here. The relation is a multiple of. So you can see that 4, 6, 8, and 12 are all multiples of 2. 15 and 25 are all multiples of 5. So in this case, the relation here is a multiple of. Somebody can also say the relation is greater than, because when you come here, you can see that 4, 6, 8, and 12 are greater than 2. 15 and 25 are also greater than 5. So here we choose to go with is a multiple of, because it gives a better description of the relation that we have here. Let's look at the last type of relation that we are going to consider. We've considered one-to-one, we've considered one-to-many, we've considered many-to-one. Lastly, we are going to consider many-to-many. In this relation, several elements in the domain have many elements in the codomain, and several elements in the codomain have many elements in the domain. What does this mean? Let's pick an example and see what this means. In this example, we can see that we have 2 and 3 in the domain. We have 12, 24, and 30 in the codomain. Now let's look at this. It says that several elements in the domain. Remember, when we say several here, we mean more than one. So here we have 2 here, so it qualifies as several. Now these several elements, 2 and 3, they have many elements in the codomain. So when you see here, you can see from here that 2 and 3 are all related to 12. At the same time, 2 and 3 are all related to 24. At the same time, 2 and 3 are all related to 30. So we have many. Here 2 qualifies as many. We have many relating to many. We have many in the domain relating to many in the codomain. In the same way, we are saying that several elements in the codomain have many elements in the domain. In the same way, 12 here, 12 and 24, which also qualifies as many, is related to 2. The same time, 12 and 24 are also related to 3. At the same time, 24 and 30 are related to 3. 24 and 30 are also related to 2. 12 and 30 are related to 3. 12 and 30 are also related to 2. So we have many in the domain relating to many in the codomain, then many in the codomain relating to many in the domain. So when this happens, we see that you have a many to many relation. So in this case, the relation is a factor of. So you can see that 2 and 3 are factors of 12. At the same time, they are factors of 24. At the same time, they are factors of 30. Thank you for watching this video on relations. I hope you understood everything that was explained here. If you have any problem, interact with me on our social media handles and I'll help you to understand. In the next video, we are going to look at mapping and we will see how to find the rule of a mapping. Bye-bye.